Okay, so again, this is one of those integrating factor questions, right? Because it's not exact. So, integrating factor method. Okay. Let's call that integrating factor in U of X. So this is the method of integrating factor. So we rewrite the differential equation and multiply each side by mu. And we notice that the left-hand side is just d over dx of y times mu, and this is equal to ux cubed. Let's call this equation star. We will come back to it. And now let's expand this. So this will be mu y prime minus or plus y mu prime equals mu x cubed. And if we compare these two equations, we can't fail to notice that for those to be equal, since the first term is the same and the one on the right of the equal sign is the same, for the middle one to be the same, mu prime has to equal minus 2x mu, which makes d mu over dx equals minus 2x mu. Separate the variables, so d mu over mu equals minus 2x dx. And now we can integrate both sides to find the integrating factor. So then we get mu to equal minus x squared. So ln mu, the left hand side is ln, the right hand side is minus x squared. Therefore, mu is equal to e to the minus x squared. Did you get e to the minus x squared as your integrating factor? I think you forgot the minus sign. Yeah. So now we will plug this in equation star. So let's change the color. So star becomes d over dx of e to the minus x squared times y has to equal mu times x cubed. So x cubed e to the minus x squared. And now what we can do is we can move this dx here and we can integrate both sides, and the integral just replaces the derivative and we get the actual function inside on the left hand side, because the integral will undo the derivative. And then on the right hand side we will use u sub first to try to simplify this integral, right? So let's do that. So if we call put a line here, let's call u to be x cubed, which makes du to be 3x squared dx. And then so this becomes this becomes e to the, or actually, sorry, I meant to say e minus x squared to be u, which makes du to be minus 2x dx. So now this integral becomes, so x cubed is the same thing as x squared times x. So this will be u, or minus u. So it's minus x squared, and this is e to the u. And x dx will just be, actually let's call this w for reasons that I will explain in a second. So this will become minus w, and this is e to the w, and then x dx, because we have one x left from x cubed, becomes dw over minus 2. You understand the integration here? So now we pull this half out, and we get w e to the w dw. And now we can use integration by parts on this one, and that's why I reserved the u and v for integration by parts. Okay, so from this down, let's change the color to black here. So by parts on this one. So u
Wouldn't it be
will equal w.
wouldn't that be w to the 1/2, or to the 1 and a half? Because e to the w, the x squared, or negative.
No, look at the breakdown. The breakdown happened as follows: x cubed is x squared times x times dx.
Oh yeah. And
okay, so x dx is dw over minus 2.
Right.
X squared is minus w, and e to the minus x squared is e to the w.
Right.
So that's how we got this. Okay. Okay, so back to by parts. So u equals e to the w, which makes du equals dw, and dv equals e to the w dw, which makes v equals e to the w. And now again, integration by parts formula entails u dv equals uv minus the integral of v du. This is the by parts. Okay, so now back to this equation here. Continuing from the integral, we will get e to the minus x squared y is equal to 1/2 uv, which will be w e to the w, minus the integral of v du e to the w dw. And we know what w is. W is just minus x squared, so we will replace it right now. So minus x squared y equals 1/2 minus x squared e to the minus x squared, and the integral of e to the w is just e to the w. So we will write this as e to the minus x squared plus c. And now finally, to find, we're done with the integration. To find y, we will divide by e to the minus x squared. So we will get y equals 1/2 minus x squared. And we divide each one of these by e to the minus x squared. And this one will give us minus 1 plus c over e to the minus x squared is the same exact thing as c e to the plus x So this will be the solution of our differential equation using the method of integrating factors. So any questions on this process here? Okay, let's verify this using the software. Yep, and then it indeed checks out.